Cloud computing by Sorted Incorporated. Our objectives are simple: to determine what cloud computing is and how it works, to determine the different service models and infrastructure used in cloud computing, and to determine some of the benefits and risks involved. Here we can see the basic connections involved in a cloud system.
What is the cloud? In simple terms, it is a virtual environment where applications and data can be stored in a web-based environment instead of being physically with the user.
Service model, software as a service. Applications are designed for end users delivered over the web. Platform as a service is the set of tools and services designed for coding and deploying those applications quick and efficiently. Finally, infrastructure as a service is the hardware and software that powers it all.
Deployment models. Private cloud is operated solely for a single organization, whereas public cloud services are rendered over a network that is open for public use. Community cloud shares infrastructure between several organizations from a specific community, and hybrid cloud is a combination of two or more clouds.
Here are a few extra points regarding the deployment models.
How it works. To understand the workings of a cloud computing system, it is easier to divide it into two sections, the front end and the back end. They are connected to each other through a network, usually the internet. The front end is the side that is visible to the client, customer, or user, while the back end is the cloud section of the system.
Here we can see the link between the front end and the back end of a cloud service.
The front end consists of the client's computer or computer network and the applications essential to accessing the cloud computing system. It is not necessary that all cloud computing systems have the same user interface.
On the back end of a cloud system, there are various computers, servers, and data storage systems that make up the cloud. A cloud computing system could potentially include any computer program, from data processing to video games. Generally, each application will have its own dedicated server.
Now, let us look at some benefits.
1. Lower capital costs. Organizations can provide unique services using large-scale computing resources from service providers. It can then nimbly add or remove IT capacity to meet peak and fluctuating service demands while only paying for the actual capacity used.
2. Lower IT operating costs. Organizations can rent added server space for a few hours at a time rather than maintaining proprietary servers, so they don't have to worry about upgrading their resources whenever a new application version is available. They can also host their virtual IT infrastructure in locations offering the lowest costs.
3. Higher efficiency. Organizations may be able to optimize their IT infrastructure and gain quick access to computing services required.
Now, for some risks.
1. Network dependency. The most basic drawback of cloud computing is that you need an internet connection to access the cloud. This means that the system is prone to outages and service interruptions. These could occur in the middle of a task or transaction, meaning that the action could be delayed or lost entirely if time sensitive.
2. Centralization. Organizations usually outsource data and application services to a centralized provider. In cloud computing, we know that network dependency is a drawback due to outages. Centralized data can certainly add another risk to cloud computing. If the provider's service goes down, all clients are affected. 3.
Data integrity or security. There's already a huge risk with data hosted in-house, so it's no secret that data off-site sits at an even higher risk. With data off-site, more avenues for attack, and the fact that it'll be traveling more makes it easier for it to be intercepted.
So, is cloud computing really worth the risk? I'll leave that up to you to decide.
Created using Powtoon.